All right, so another real world. So modeling is real world problems. So this entire unit or this entire section is about that. We could do something for growth of cells. The way we write that formula looks like this. Sorry, can't write and talk very well. So A sub t A of t equals A sub 0 times e to the kt, where k is greater than 0. So this is a part where we use e. And we can use that to figure out problems such as the one that we're about to do. A culture of bacteria follows the law of uninhibited growth. If 500 bacteria are present initially, and there are 800 after 1 hour, then how many will be present in the culture after 5 hours? So initially, remember x is 0 initially, or in this case t. There are 500 present. After 1 hour, there are 800 present. So we have to come up with the formula here so that we can use it. So what do I know? Well, I know that A sub 0, which is the initial value, has to be 500. Okay, how could I figure out what K is? Well, this is A of t. If I know this much, notice I also have another point that I could use. So I could say 800 equals 500 e to the k times 1, because t is 1. All right. Now, we have not learned how to solve when k is in the exponent, okay? So we need to do that when that's where log comes into play, which is coming up next week. So what we're going to use instead is one of our Algebra 2 skills, where we put this in y1 and this in y2 and find where they intersect, okay? So in Desmos, I'm going to put 800 in y1, and I'm going to put 500 e to the, instead of k, remember we always use x, whoops. Okay, remember to always use x. It's actually x times 1, but that's not necessary. We're going to have to zoom way out here. Oh, 800 won't work. We do have to put y equals in order for that to graph. All right, so we want to know where the blue and the red cross. And they cross at 0.47. So that means that k must equal approximately 0.47. All right. All of that just to set up the function. We haven't even answered the question yet. The function that we use now looks like this. Okay, we got the 0.47 from here, and then the 500 was the initial value. We want to know what's it going to look like after 5 hours. So we can sub in 5 and do the math, right? Totally cool. We can also so we now know that this is 0.47x I know we use T, but we can look at that table, and we want to know at 5. So when it is 5, there is approximately 5,243 bacteria. So if you want to just type it in your calculator, one is as easy as the other because either way you're having to type it in your calculator, so it depends if it's already in there. So I could type that entire block in, or I can do the graph way that I just showed. Either way, I'm getting 5,243 bacteria if I round. That's pretty amazing. You go from 500 and then 5 hours later you have 5,243. Okay, what about how long before the culture contains 20,000 bacteria? So that means that A sub T, the Y value is 20,000 this time. Okay, so we're going to get 20,000 equals our function. So 500 e to the 0.47 t. Again, this, I could divide by 500, and then I would have to do something called ln to solve. We haven't got that far. I promise we will. So if you want to revisit this in the solving manner later, then absolutely we can. But for now, let's use our resources and solve using our calculator. I shouldn't have exited that one out, but that's okay. 20,000. Again, we need y equals. Anytime it is just a number by itself, Desmos freaks out and doesn't know what to do. So if it's just a number, you have to put y equals. And then 500 e to the 0.47x. Gonna have to zoom way out because 20,000 is way up there. There we go. So I'm at 20,000 at approximately 7.85. So T would have to equal approximately, 7.85 hours. Now remember, that is not 7 hours and 85 minutes, because if that were, that would actually be 8 hours, right? So to figure out how many minutes 0.85 is, well, there's 60 minutes to an hour. And we want to know 0.8, we could even say 48 to get a little more accurate there. So 60 times 0.848 is approximately 51 minutes. So T, it's approximately 7 hours and 51 minutes. So recap, after 7 hours and 51 minutes, there will be approximately 20,000 bacteria.